Hi, 6th graders. Mrs. Freeman here. Tonight's lesson 4.6 is our final lesson in this unit. It's on fair and unfair outcomes. Seem to think you're pretty familiar with those terms. Well, our objectives are I can determine the number of possible outcomes by using a tree diagram, calculate the probabilities of outcomes using a tree diagram, and analyze the fairness of games of chance. First, we'll start by getting a couple of vocabulary words in our notebooks. A game is fair for two or more players if each player has the same chance of winning. The same holds true for one player if the player has an equal chance of winning or losing. And an unfair game is when one or more players do not have an equal chance of winning. First example, I want you to imagine two black counters and one white counter that are placed into a bag. Without looking, you'll draw out a counter, then draw a second counter out without putting the first counter back into the bag. So if the two counters are the same color, you win. So down below you can see the results of a class of 26 students. We need to find the total number of wins. So how we'll do that is take the students, 2 times 0, 0 wins, plus 6 students had 1 win in their game, 8 students had 2 wins in their game, and 6 students had 3 wins, and 3 students had 4 wins, 1 student had 5 wins, and no students had 6 wins. That gives us a total of 57 wins. So each student played 6 games, so 26 times 6 is 156. So our denominator is 156 because that's the total number of outcomes, the total number of games played, and 57 of those games were won. So that works out to roughly about 1/3 of the games were won. This game does not represent a fair game. If it was a fair game, half of the games would have been won, 50-50 or 50% or 1/2. Another way to look at the data is to put it into a tree diagram. So you can see the 3 outcomes, the black 1 counter, black 2 counter, and white counter outcomes. And since there's 3 outcomes, that's our denominator, and 1 is our favorite outcome, whether it's black 1, black 2, or white. Then you can see that we have 2 outcomes left in the bag. There will always be 2 counters left behind after you choose the first counter. So the denominator is 2 and the outcome is 1. There's a possibility of choosing 1 more counter. So we can take our 1/3 outcome for our first draw and multiply it by our second outcome, 1/2, and we get 1/6. So there's 6 possible outcomes for drawing out a counter out of the bag. We can follow the path of a counter on our tree diagram. If we draw a black counter out and then followed by another black, that happens 1 out of 6 times, in theory. We could also draw a black counter the first time, but black 2, and then follow up by our second draw being black 1. So again, we have a 1 in 6 chance of doing that. So there are a total of 6 outcomes, 2 of which result in having the same colored counters. So only 2 out of 6 trials will result in a win. Therefore, this game is not fair. Let's take a look at game 2. Game 2 uses 2 black counters and 2 white counters, but the rules are the same. So you can see from our tree diagram there are now 4 outcomes, B1, B2, W1, W2, and each has an equal chance of occurring. So it has a 1 in 4 chance, theoretically, to be chosen. When we add on the second counter that can be pulled from the bag, there are 3 counters left. Therefore, there are 3 possible outcomes. So for example, if we were to draw B1 first, and then for our second draw, we pulled out we pulled out W1, okay, that would happen 1 out of 12 times. So again, we can take our first outcome, 1/4, times our second outcome, 1/3, and we end up with 12 possible outcomes. So there are 12 possible outcomes. Now if we want to look at outcomes that will result in a win, we want to have our first draw be a black and our second draw be a black. And that would result in a win. So there are 4 possible outcomes that would result in a win. So that's 4 out of 12. Well, 4 out of 12 isn't even half of a chance of winning this game. So therefore, this game isn't fair either. Now it's your turn to check game 3. Make a tree diagram. Find the theoretical probability for each outcome and how many outcomes total there are, and decide if the game is fair or unfair. Click play when you're ready to check your tree diagram and your theoretical probability. Remember our spinners from the previous lesson? We determined that they had 3 congruent parts, and we listed the possible outcomes for spinner A and spinner B. But let's determine now if it's a fair game. First thing we'll do is determine the winner. We can count up how many times out of 9 A occurred, and we can see that that occurred 4 out of 9 times. Outcome B occurred 5 out of 9 times. So if we were to play this game, it would not be a fair game. We worked with the spinner above, or spinners above, C and D, and there's our tree diagram showing the theoretical probability. Spinner C won 2 out of the 8 times. Spinner D won 6 out of 8 times. To find this percentage, we can easily make a cross product pair, a proportion, and we get 25%. Suppose you're playing dueling spinners with the spinners that are shown. Find values for spinner C and sketch a tree diagram so spinner A wins 40% of the time. Use guess and check to help solve this problem. Press play when you're ready to check your tree diagram and your possibilities for spinner C. So again, 6th graders, tonight's lesson is 4.6 on fair and unfair outcomes. I can determine the number of possible outcomes by using a tree diagram, calculate the probabilities of outcomes using a tree diagram, and analyze the fairness of games of chance. Review any part of this video you need to, then head on over to schoology.com and take the quiz. See you!